We've covered a lot of material in this module, so let's take a few minutes to review. First, we talked about preparing to schedule our project. And there are many processes within the project time management knowledge area, as well as others, that make developing the schedule possible. Some of the key processes include planning schedule management, figuring out how we're going to go about this scheduling process in the first place, as well as defining our project activities, sequencing them, discovering any necessary dependencies or preferred orders for the way that activity should be accomplished, as well as estimating activity resources and durations. Once we have this information in hand, we can use it through the lens of scheduling tools and a schedule methodology to create the schedule model. The schedule model determines planned start and finish dates for activities and explores project possibilities. What if we do tasks this way? What if we go about them this other way? Maybe we should change the sequence of these, or perhaps we should use resource A instead of resource B on this particular activity. We can experiment. We can see what the impacts are of these various changes. Talk it over with the rest of the project team, as well as a variety of subject matter experts, so that we can hone in on the ideal schedule for our project. This is a highly iterative process that's greatly influenced by the chosen scheduling method as well. Whether we go with critical path, critical chain, or some other methodology, it's going to have a drastic impact on the way we go about doing things like dealing with contingencies in particular. Now, the critical path method is very useful because it can estimate the minimum project duration. What is the least amount of time it will take to go from the very beginning until the very end of this project? The critical path can also determine where flexibility exists in the schedule, as represented by float or slack, time in the schedule where we might not need to move immediately from one activity to the next. Now, any delays in activities that are found on the critical path will likely delay the entire project, which makes the critical path, well, critical. Activities not on the critical path, on the other hand, do offer more flexibility. These are the ones that exhibit that float or slack and allow us a little bit of leeway in the way that we approach those, either in the way that we've assigned resources to them or when we have those resources actually tackle the activity in question. Now, there are two types of this float or slack that can exist. The first is total float. This is the amount of time an activity may be delayed without impacting the project overall. Any more time past what the total float would allow, and we're looking at delays that cascade throughout the project. Free float, on the other hand, is the amount of time an activity may be delayed without impacting its successor. When we talk about the critical path, a grid like this one is often used in order to visualize each different activity and so that we can understand what must take place as we continue to progress. Now, the top row is determined using what's known as a forward pass. In other words, we network out all of the different activities that we expect to take place on the project in the sequence that we expect them to take place, from start to finish. And then we move from left to right across this diagram, filling in the early start, the early finish, and the duration information. All of these we can derive based on the estimate activity durations that we did using a prior process. Once we get to the end of the schedule, we can now work backwards with the backwards pass to determine what the bottom row would be. We begin with the late finish, which allows us to also determine what the late start could be. These numbers, as well as the early start, can inform what our total float might be and help us to discern whether an activity indeed lies on the critical path or if it has some float and some leeway with which we can work. Now, the critical chain method is similar to the critical path in the way it's constructed, but improves upon its methodology in a few key ways. First of all, it addresses the assumption that is built into the critical path that unlimited resources are available. After all, in the critical path, we assume that if one activity is done, we can just move right into the next one, or that several unrelated activities can occur concurrently, when in fact they might use the same resources even if they don't have directly related precedents or successors. Now, the critical chain uses aggregated buffers. Instead of the slack or float, the activity level contingencies that we see with the critical path. See, the only way that we can deal with these kind of issues, such as resource allocations with the critical path, would be to build in extra time at an activity level. But the critical chain solves that by allowing us to combine any resource unavailability with any unanticipated risks that we might want to build in some extra time for. We can lop all of this together into a few large buffers, two in particular. The first type is the project buffer. This is found just before the completion of the project, and it helps keep the entire project from falling behind. So this can be drawn on even by critical chain activities. The second are feeding buffers. Now, these appear just before any non-critical activities intersect again with critical activities moving forward. And these buffers help to ensure that the non-critical activities don't cause delays along our critical path. Because it's so unlikely that we'd need to use our contingencies on every single activity, we can actually use much smaller buffers that might be required if we were to build in contingencies at the activity level. That can lead to some savings in terms of our schedule and also lead to increased motivation for all of our project work to continue at the greatest pace possible, because we can continue to build up that buffer or draw less from it than we might fear we need to otherwise. That will leave more comfort for us in the future of the project, whereas we would consider that slack or that float to be gone on the critical path once we've gone past the activity that might have it, regardless of how long it might have taken to accomplish. In the next module, we're going to talk about resource optimization and schedule compression. We'll look at topics like resource smoothing and leveling, fast tracking, and crashing, what each of these mean and how you can utilize these as a project manager to help keep your project on schedule. I'll look forward to seeing you then.